Is this a geometric sequence? If so, what is the common ratio and what is the recursive rule? We have a sequence 4, 2, 1, 1/2, and it continues on. How can I tell if this is a geometric sequence? And what is a common ratio and what is the recursive rule? Chloe is here with her latest tips and tricks. She wants you to know that when you have a geometric sequence, you will be multiplying the same number when you're going from left to right, and you will be dividing the same number if you were going right to left between each pair of consecutive terms. The common ratio finds the ratio between two terms. It's r equals a sub n divided by a sub n minus 1. The recursive rule does depend on one or more previous terms to generate new terms. That formula is a sub n equals r times a sub n minus 1. And the explicit rule does not depend on previous terms to find the nth term. That formula is a sub n equals a sub 1 times r raised to the n minus 1 power. Now that we have Chloe's tips and tricks, let's go ahead and determine if this is a geometric sequence and find the common ratio and the recursive rule if it is. So in order to determine if it's a geometric sequence, Chloe let us know that when you're moving left to right in the sequence, you have to multiply the same number between consecutive terms, or if you go right to left, you have to divide the same number. So when I'm looking at this, I actually like to put them in a chart, and I like to label the positions. So a sub 1 is 4, a sub 2 is 2, a sub 3 is 1, and a sub 4 is 1/2. So once I have them all in a little chart like this, I am going to go ahead and use the common ratio to find that number that they're either being multiplied left to right or divided by left from right to left. So this common ratio formula here is r equals a sub n over a sub n minus 1. So when I am doing any kind of ratio, I always like to start at the end to find the common ratio. So I'm going to make my n equal to 4. So that would be a sub 4, and then instead of a sub n minus 1, it'll be a sub 4 minus 1. Well, that will reduce to a sub 4 over a sub 3. So if you notice, the common ratio formula, all it's telling you is pick one term, divide it by its previous term, and you will get the common ratio. So my a sub 4 is 1/2, my a sub 3 is 1, so I have 1/2 divided by 1. Anything divided by 1 is just 1/2. So between a sub 4 and a sub 3, my common ratio is 1/2. Let's see if I have the same common ratio between a sub 3 and a sub 2, and then between a sub 2 and a sub 1. So I'm going to take a sub 3 divided by a sub 2, so that'll be 1 divided by 2. And then between a sub 2 and a sub 1, I would have 2 divided by 4, and I can reduce this. 2 divided by 2 would be 1, 4 divided by 2 would be 2, and so this one actually reduces to 1/2 as well. So I do have the same number that I am either multiplying if I go left to right or dividing if I go right to left. So my common ratio is r equals 1/2. And I can always test that out. 4 times 1/2 is 2, 2 times 1/2 is 1, 1 times 1/2 is 1/2. Or I could go the other way. 1/2 divided by 1/2 is 1, 1 divided by 1/2 is 2, 2 divided by 1/2 is 4. Now that I have my common ratio, let's go ahead and figure out what the recursive rule is for this problem. So the formula for recursive rule is a sub n equals r times a sub n minus 1. And you can see on this problem that all we have to do is figure out or plug in our r, which we know is 1/2. So my a sub n is 1/2 times a sub n minus 1. Now, the way to write this properly is to get rid of that multiplication symbol. You don't really have to write it. So it's 1/2 times a sub n minus 1. And every time you write a recursive rule, you have to write what your first term in your sequence is. So my a sub 1 equals 4. So I have my recursive rule and my common ratio, and I also know that this is definitely a geometric sequence because we had the same common ratio between consecutive terms.